Hello everyone and welcome back to Diksha Karnataka YouTube channel. Today we are going to discuss the solution for 14th KPL. So 14th match is already over. Okay, if you are still wondering, I will start, and if you have not yet started, then you are too late. But we have already completed 14 matches. You still have some time, but the road that we have already left is maybe too much for you if you are not starting right now. Okay, so I request everyone to start right now. We have completed the entire syllabus of PU1 and PU2. Okay, the link of the playlist is in the description below. You can check that. Also, if we are doing anything new, you can join our WhatsApp channel. The link is given in the description below. Now, without any delay, let's start with today's discussion. Today's chapter wire, waves, oscillations, and one chapter from second PU as usual, ray optics and optical instruments. So these three chapters consist this KPL 14, and if you have not yet solved it, stop this video, pause this video, download the question paper from our WhatsApp channel, and you can answer that question quickly, and then you can come back to this video. Okay, so let's start with the first question. A 10 kg metal block is attached to a spring of spring constant 1000 Newton per meter. Okay, a block is displaced from equilibrium position by 10 centimeters. So mass of the block is given 10 kg. Okay, the spring constant is given 1000 Newton per meter. Okay, and the block is displaced from its equilibrium position by 10 centimeter and released. The maximum acceleration of the block. This is a very simple question. There is a mass spring system where you have displaced the mass and you want to calculate the maximum acceleration. Now this is actually, even though the question is belongs to oscillation, you can solve it even without knowing anything about oscillation. Only thing that you need to know is the how much force is applied by the spring, maximum amount of force. So maximum amount of force applied by the spring is basically Kx. Okay, without any sign. Okay, there is a negative sign because it is a restoring force, but we are ignoring the sign. So Kx is the maximum amount of force. What is K? K is the spring constant. K is spring constant. Okay, and X is the displacement. Okay, now everything has to be in SI. Now from second law of motion, we know that if the mass of the object is m and acceleration is a, then this force should be equals to ma, right? So Kx should be equals to ma. So second law and some knowledge of spring is you just require to solve this question. So now you have to calculate this a. This is for a maximum. Okay, for maximum acceleration this formula is still valid, right? Now let's put the values. K is 1000 Newton per meter, X is 10, but 10 centimeter. So centimeter to meter, as I say always, 10 to the power minus 2, and mass is 10 kilograms. Okay, so 10 kilograms, 10 cancels, and 10 to the power minus 2, 1000, so you will get 10 meter per second square. So your answer will be 10 meter per second square. Okay, simple. Next question. A particle executing SHM has maximum speed 0.5 meter per second and maximum acceleration of 1 meter per second square. The angular frequency of the oscillation. This question is very common. So what is the maximum acceleration? In terms of angular velocity, we know that that is omega square times a. A is the amplitude of the motion. Now the amplitude is not given, but we don't require because we know that velocity max is given by omega a, not square. Okay, so velocity max is given by omega a and acceleration max is given by omega square a. So we just need to divide them. So a max divided by v max equals to omega square a divided by omega a cancels, so it will be only omega. So omega equals to a max by v max. So what is a max? Maximum acceleration is 1 meter per second square, so 1, and maximum speed is 0.5 meter per second, so 0.5, so it will be 2. Okay, 2 radian per second. Okay, simple as that. So we can see the answer is option A. We don't need to go further anywhere other than option A. So option A is the correct answer. Very easy question. It should not take more than 30 seconds to answer. Next question, question number 3. two simple pendulums A and B are made to oscillate simultaneously. Okay, two pendulums, they are oscillating simultaneously, and it is found that A completes 10 oscillations in 20 seconds and B completes 8 oscillations in 10 seconds. The ratio of lengths of A and B is. So what is the time period? So time period for pendulum 1 is given by total number of total time taken divided by total number of oscillations. So time taken is 20 seconds and oscillation is 10, so time period is 2 seconds. Okay, and what is T2? T2 is again 8 oscillations in 10 seconds. Sorry, 10 seconds in 10 seconds, 8 oscillations, right? So first will be time, because we are calculating the time period. Number of oscillations will be in the denominator, in the division, right? So whatever it will be 5 by 4. Let me write it in like that only. Now what is the formula for time period in terms of length? The formula for time period is given by 2 pi root over of L by G. Okay, so the formula for time period is 2 pi root over L by G. So we can say that T1 by T2 will be equals to square root of L1 by L2. So directly proportional, from here we can say time period is directly proportional to square root of L, right? Rest of them are constant. Okay, so square root of L. So from here we can say T1 by T2 is equal to square root of L1 by L2. Okay, so or L1 by L2 is basically T1 by T2 whole square. As simple as that. So let's find that. So L1 by L2 equals to T1 is 2, T2 is 5 by 4 whole square, or 8 by 5 whole square, or 64 by 25. Okay, so L1 by L2 is 64 by 25. Okay, so be careful when you are answering that this kind of questions. Sometimes L1 by L2 you are find, but in the question they have asked you to find L2 by L1. So be careful what is to what you are trying to find. Deliberately they change the language, so that even if you have done the calculations correctly, instead of answering the correct answer, you answer the wrong answer. Okay, so be careful, and if there is no other options given, then it is fine. But when the options are opposite to each other, that means there is a chance that you may have done a mistake. So be careful, check it once and answer it. You have enough 1 minute time to solve such questions. Next, question number 4. So this kind of question, statement based questions, you have to read, figure it out quickly and answer it less than 20 seconds. That is the best way, right? Now this is a statement based question. A pendulum oscillates in simple harmonically if and only if the size of the bob of the pendulum is negligible in comparison to the length of the pendulum. Obviously we know that if the length is bigger than the size of the pendulum bob, then definitely it's a simple harmonic motion. But there is one more condition, that the angular amplitude is less than 10 degrees. Yes, if the angular amplitude is more than 10 degrees, there is a small angle approximation that we apply is no longer applicable. So you cannot consider that to be a simple harmonic motion. Even though it's a oscillatory motion, it's a harmonic motion, but not simple harmonic motion. Okay, so these two conditions are necessary for it to be a simple harmonic motion. Okay, be careful. Simple harmonic motion is not the same as oscillatory motion. Oscillatory motion can be anything, but simple harmonic motion specifically requires you to fulfill certain conditions. Okay, if you want to learn about those conditions, you can read your NCERT book. Okay, so what are those? Both 1 and 2 are correct. Yes, option A is correct answer. So it should not take more than 20 seconds to answer such questions. Next, for a particle executing simple harmonic motion at its mean position, okay, so particle executing simple harmonic motion, for example the pendulum example we have taken, okay, at the mean position, what happens at the mean position? Now at the extreme position velocity becomes 0, that's why it stops momentarily, okay, but its acceleration is maximum. At the mean position its velocity is max, acceleration is 0. Okay, so velocity is maximum and acceleration is 0. So option B is the correct answer. Okay, other options you can read through it once and you can ignore that. You have to remember that at the extreme position, okay, velocity is 0, acceleration is maximum. At the mean position, velocity is maximum, acceleration is 0. Okay, because it is the, suppose this is the ground level. If this is the ground level, G should be even though there is a gravitational acceleration acting downward, the component of G will be 0. Right? Now question number 6. This is a equation based question. The displacement of a particle executing SHM is given by x equals to 3 sine 2 pi t plus pi by 4, where x is in meters and t is in second. Okay, the amplitude and the maximum speed of the particle. So amplitude is given by this quantity. So all the options given the same amplitude, no other options were given. So obviously they want to check the speed of the particle. Okay, so what is the speed? Speed is, maximum speed is omega a. Okay, so what is omega from this equation? So we know that normally equation is given by a sine omega t plus phi. Okay, so omega t, here if you compare these two equations, you can see that omega is 2 pi and a is 3, right? And the phase difference phi is pi by 4. We are not interested in that. We want to find the omega. Omega is 2 pi and amplitude is 3. So 6 pi is the answer. Okay, 6 pi is the maximum speed. 3 meter and 6 pi meter per second is the answer. So the only one answer is this. Question number 7. The ratio of kinetic energy to the potential energy of a particle executing SHM at a distance equal to half its amplitude, the distance being measured from its position of equilibrium is. So first of all, let us understand what is the formula for kinetic energy. Kinetic energy Ek is given by half m omega square, okay, a square minus x square. This is the maximum kinetic energy, and maximum potential energy is not maximum actually, half m omega square x square. Okay, so this is the maximum potential energy. This is the equation for kinetic energy. This is the equation for potential energy. Now they have said that at a distance equal to half its amplitude. So at a distance means x equals to half of the amplitude. So you have to understand this question. This is slightly longer question than other questions. So you have to do the step by step. First calculate the kinetic energy. Kinetic energy is half m. In fact, if you are smart, you can ignore this term because they will cancel anyway. Only thing that you have to calculate is this, a square, but I cannot do that. I am a teacher. I want everything to be perfect. So, but if you are smart, then you can ignore that and you can simply calculate what is the ratio of the amplitudes. Okay, so half m omega square 3a square by 4. Okay, and what is the potential energy? Potential energy is half m omega square, okay, a by 2 whole square, that is half m omega square a square by 4. Okay, now we have to find the ratio of kinetic energy to the potential energy, right? So Ek by Ep. So what is Ek? Ek we have calculated 3a square by 4. Now I can ignore this term because they will cancel anyway, right? And what is potential energy? Potential energy is a square by 4. So a square cancels. This by 4 cancels. So it rests 3 by 1. So the ratio is 3:1. Okay, clear, simple answer. Now in this case you can sure, even if you have done the wrong calculation, even if you have done the wrong formula, you will get the answer as 1:3 maximum. Okay, in that case, but there is no other option of 1:3, so you can guess, okay, maybe I have done something wrong. The answer should be 1:3, 3:1. So that is fine if you have done the process properly and the options are not matching in some case, but you find some answer which is exactly opposite to that of your calculated answer, then you should know that answer should be opposite to that. But if they have given an answer where it mentions 1:3 also, then you will have a wrong answer. So you have to be careful when you are solving such questions, especially the ratio related questions. Now question number 8, the speed of sound in air in an ideal gas is given at temperature T is V. The RMS speed of the gas molecules at that temperature is Vrms. The ratio of velocities of V and Vrms for helium and oxygen gases are X. So for helium it is X and for oxygen it is X dash. Okay, now we have to find the ratio of X is to X dash. This is a previous year questions. So first we need to know what is V. V is gamma P by rho. We have done during our class. V equals to gamma RT by M. We can convert gamma P by rho into gamma RT by M, and Vrms is square root of 3 RT by M. So V by Vrms equals to gamma by 3. Everything else will cancel. You can do that and you will find V by Vrms is gamma by 3. Now for oxygen, for helium is a monoatomic gas, right? We know that helium is an inert gas, so it does not have its atomicity is 1, so monoatomic gas. So for it, gamma will be equals to 5 by 3. Okay, and for oxygen is a diatomic gas. Okay, for oxygen gamma will be 7 by 5. So if you remember only one of them, monoatomic gas, based on the how many atoms are there, so 2 atom means diatomic means you have to add 5 plus 2 divided by 3 plus 2. This is the way you should remember it. Okay, if you remember for monoatomic gas, I ask you to remember only one, monoatomic gas. For diatomic gas, you have to add 2 in both cases. For triatomic gas, you have to add one more set of 2 in both cases. Okay, don't add 3. You have to add another 2. Okay, so it will be 9 by 7. Okay, so that will be the that's the process. Now we have to use the given information that X is for helium and X dash is for oxygen. So X will be equals to gamma for helium divided by 3. Now what is gamma for helium? Gamma for helium is 5 by 3. So 5 by 3 divided by 3, that is square root of 5 by 9. Okay, now what is X dash? X dash is gamma for oxygen, that is 7 by 5 divided by 3, so it will be 7 by 15. Okay, now what we are trying to find? We are trying to find the ratio of X by X dash. So X by X dash equals to square root. I am taking the square root common because both has square root. So let's do this. 5 by 9 divided by 7 by 15. So if there is a division, what we can do? We can simply remove the division and we can make it multiplication, but with the reverse order, 15 by 7, right? So 3 3 the 9, 3 5 the 15. Okay, so what we get? 5 square root, 5 into 5 square root, so 5 will come out of square root. 3 7 the 21, so square root of 21. So the answer is 5 by square root of 21. So 5 divided by square root of 21. So this is the answer. Tell me if you have got the same answer or if you have received any different answer in the comment below. The equation of a stationary wave is y is equal to 2 sin pi x by 15 cos 45 pi t. the distance between a node and its next antinode is. Now the normal equation for a stationary wave is given by A sine kx times cos omega t. Okay, so this is the basic equation for a stationary wave. Now if you compare this from this equation, you can see that the value of k is given by pi by 15. Okay, so pi by 15 is the value of k. Again we know that k is the wave number, that is, this is given by 2 pi by lambda. Okay, so you have to calculate the lambda from here. Lambda is basically you can see lambda will go here, 2 times 15 equals to 30. Okay, 30 units, no measurement is given, so let me write in units. 30 unit is the lambda. Now the distance between two corresponding node and antinode, okay, node and antinode is given by lambda by 4. It is always true, right? So corresponding node and antinode is always lambda by 4, right? This is we have learned in our class. So we can say 30 divided by 4, that is 7.5 units. So answer is 7.5 units. Okay. Next question, question number 10. The first overtone frequency of a closed pipe of length L1 is equal to second harmonic frequency of an open pipe of length L1. The ratio of L1 by L2. This is L2, sorry. L2. Okay, so the first overtone frequency of a closed pipe of length L1 is equals to the second harmonic frequency of an open pipe of length L2, the ratio of L1 and L2. So this is slightly not difficult, but you have to draw the diagram, that's it. So first we will draw the closed pipe. Okay, second harmonic, second overtone, they mean the same thing. Okay, there is no difference between second overtone and harmonic. They are on the only thing, that is the second frequency. Primary frequency or the main fundamental frequency is this for a closed pipe, right? So difference is lambda by 4. Now the second overtone is given by when you can form two loops, right? So remember that for a closed pipe there always will be a node and there will be always an antinode here. Okay, this is always will be true for a closed pipe, right? Now what is the distance? Suppose the wavelength is lambda 1 for pipe 1. So this is lambda 1 by 4, right? This distance is lambda 1 by 4. If you remember the formulas very well, if you don't remember the formulas, you can use this. Okay, lambda 1 by 4, and this is lambda 1 by 2. Okay, why? Because here we are measuring the distance between two consecutive nodes. Two consecutive nodes, the distance is lambda by 2. The distance between one antinode, one node is lambda by 4. Okay, so this is lambda 1 by 4. Now the length is given here is L1. So this L1 should be equals to this wavelengths, right? So lambda 1 by 2 plus lambda 1 by 4, that is 8 by sorry, not 8, my mistake, 2 and 4 LCM is 4, so it will be 2 plus 1 lambda 1 or 3 by 4 lambda 1. So this is the closed pipe. Now we know that velocity of sound is equal to frequency times lambda. That is the relationship, right? For first node, say the frequency is 1, nu 1. So nu 1 equals to V by lambda 1. Now what is lambda 1 from this? Okay, so as you can see, the lambda 1 from this is 4L1 by 3. Okay, so put the values. V by, we don't want, actually our target is not to get any values from using lambda, so we will remove it and we will put the values in terms of L1, L2. Okay, so this is the equation for closed pipe. Now what is that for open pipe? Now again second harmonic is there in open pipe. So open pipe, first harmonic is like this, second harmonic is when you get a wave like this. This is the second harmonic in closed pipe, right? Now you have to understand that in closed pipe both sides will have an antinode, okay, and node at the between, okay. Generally only when first primary wavelength there will be one node, for secondary or second harmonic there will be two nodes, right? So here we have two nodes. Now this wavelength, say lambda 2, so lambda 2 by 4 here, lambda 2 by 2 here, again lambda 2 by 4 here, okay. So what is the total length? Total length in this case, say L2, so L2 will be equals to lambda 2 by 4 plus lambda 2 by 2 plus lambda 2 by 4, so that is equals to half lambda 2. So L2 equals to lambda 2. Now what is frequency? Nu 2 will be V by lambda 2, right? We already know that is V by L2. Okay, now they have asked you find the ratio of L1 by L2. Okay, how can we do that? What is the relationship between nu1 and nu2? The first overtone frequency of a closed pipe of length L1 is equal to the second harmonic frequency of the open pipe. So they have given you that nu1 equals to nu2. Okay, so now put the values. Speed of sound in a particular medium will always be constant, right? So V will be constant no matter what type of pipe you are using. So let's put those values. 3V by 4L1 equals to V by L2. So V cancels. We are trying to find L1 by L2, right? So what is our beneficial for us? Take this L1 to the other side, then we will get L1 by L2 equals to 3 by 4. So L1 by L2 is 3:4 or 3 by 4. Okay, so this is the correct answer. Now next question, a pipe of 30 centimeter long and open at both ends produces harmonics which harmonic mode of the pipe resonates at 1.1 kilohertz source. Now even though the proper resonance is not part of the syllabus, but we know that resonance happens when the frequency is matches. So when two frequencies are equal, then there is something called a resonance. Okay, so now what is the resonance for 30 centimeter long open pipe? So first let us find the fundamental frequency for open pipe. What is the fundamental frequency? Node, antinode here, and there is a node in between. This is the fundamental frequency. So we will first find the fundamental frequency. So for this is lambda by 4. This is also lambda by 4. The length suppose is L. No 1, 2 because we are only dealing with only one pipe. So L is basically lambda by 4 plus lambda by 4, that is lambda by 2. So what is the V is equal to n lambda, so frequency is equal to V by lambda. So from here we can see that lambda equals to 2L, so V by 2L, right? This is the frequency. Now let's put the values. What is the value of V given? V is 330 meter per second. V is 330 meter per second. And what is the length? Length of the pipe is given 30 centimeter. Okay, 30 centimeter means 30 times 10 to the power of minus 2. So whenever centimeter is given and you want to convert it into meter, always multiply with 10 to the power of minus 2. That is much easier than using points, dots, etc. That might confuse you, but this 10 to the power of minus 2 will never confuse you, right? So let's cut this 11, okay, or if you take this on the other side, it will be 5.5 times 10 to the power of 2 or 0.55 into 10 to the power of 3 okay, or 0.55 kilohertz. Okay, so this is the fundamental frequency. Now if it matches with say nth number of frequency, then n times fundamental frequency should be equals to resonance frequency, right? If they are equal, then only resonance will happen, or n equals to 1.1 divided by 0.55, that is 2. Okay, so it will be the second harmonic is the answer. Okay, second harmonic, n equals to 2 you have achieved. So this is the answer, right? Next question. A stretched string is vibrating in the second overtone, then the number of nodes and antinodes between the ends of the string are respectively. Stretched string means it is like a guitar, right? This fixed like this. This is the first fundamental frequency. Okay, and first overtone is when you get like this. Okay, how many antinodes? Antinode 1, antinode 1, antinode 2. Okay, how many nodes? Node 1, node 2, node 3. Okay, so how many nodes and antinodes? So first will be number of nodes. Number of node is 3 and antinode is 2. 3 and 2. So be careful, as I said, in such questions where there is a possibility that both way is possible, so you have to read it. Be careful. Node is first, antinode is second. So node is 3, antinode is 2. Okay, the waves set up in a closed pipes are, so closed pipe generally formed using sound. So sound is longitudinal, so basically it's longitudinal, and also it is a stationary wave. So longitudinal and stationary wave. Okay, it is not transverse. Transverse wave is possible in a straight string. Okay, only in a straight string transverse wave is possible, but it will also be stationary, right? And if you are doing it in a water, transverse wave is possible, but whenever sound is involved, then it should be always longitudinal. Okay, next question. When to tuning fork, so I know that many of you have not seen the tuning fork. Some of you have seen the tuning fork in your laboratory. Tuning fork are like this. Okay, so they have like this. So if you beat it with a rubber pad, this makes sound. Okay, which is a very shrill, cute sound. Okay, and tell me in the comment below how many of you have seen tuning fork, or how many of you have done practicals using tuning fork. Okay, so when two tuning forks A and B are sounded together, 4 beats per second are heard. Okay, so the frequency of the fork is 384 Hz when the prongs of the fork A. So fork B is given, suppose this is fork B, okay, and we have another fork A. Okay, if the frequency of this is F1, and if you hear the beat frequency, say B. What is the meaning of beat frequency? Beat frequency means the difference between the frequencies. That's it. Beat frequency is nothing but the difference in the frequency. So if the beat frequency is B, then either this can be F1 plus B or F2 minus B. Both can give you the beat frequency of B, right? So in this case, what is the value? F1 is given by 384 and beat frequency is 4. So F2 can either be 384 plus 4, that is 388, or it can also be 384 minus 4, that is 380. Both are possible. Okay, both are possible, but you have to choose which one is correct. That is the solution. So either 388 or 380, either of them will be answered. These two you can simply ignore. Okay, now what is the question? When one of the prongs of the fork A is filled and sounded with B, so prong A we are trying to find, frequency of A we are trying to find. Now you have filled some, suppose you have added some wax into it, or some glue into the prong A, then what will happen? Okay, the beat frequency increases. So what is the frequency? Now you have to identify which of the case is true. Now when you add extra mass to a tuning fork, its frequency increases. okay, its frequency increases. That means if it was suppose 380, now the new frequency will be 381 after you add a small mass into it. Now what will be the beat frequency? This is already known, 384. This will again remain 384. Now what is happening to the beat frequency? Beat frequency is decreasing, right? So beat frequency is decreasing. So this is not possible, right? Here they have said the beat frequency is actually increasing. So if it was 380, then definitely it is not matching our criteria. But if it is 388, then what would happen? If it was 388 and then if it is increasing, suppose it reached to another value, say 390. Okay, it reached to another value, say 390. Now what is happening to the beat frequency? Now if you see, the beat frequency is no longer 4 but it is 6. So as you add the extra mass to a tuning fork, its frequency increases. So if the beat frequency has to increase, that means it cannot be 380 but it will be 388. So 388 is the answer. Okay, clear? So if the frequency, beat frequency decreases, in that case you could have said that the answer was 380. Okay, but beat frequency increases, that means it will be 388. So the same question can be asked as saying that what will be the beat frequency if the beat frequency decreases? Okay, in that case the answer would be 380. Question number 15. A metallic wire of 1 meter length and has a mass of 10 times 10 to the power of minus 3 kilograms. If the tension of the wire is 100 Newton is applied to a wire, what is the speed of the transverse wave? Now there is a formula for that. First of all, you have to find the mass per unit length. Mu, mass per unit length, is mass divided by length. Mass of the wire is given by 10 times 10 to the power of minus 3. Okay, divided by length of the wire is 1 meter. So it will be 10 to the power of minus 2. That is the mass per unit length of the wire, right? Kg per meter. Now what is the speed of a transverse wave? Speed of a transverse wave in case of a straight string is given by T by mu. This is a new formula that you have learned. Okay, tension in this case is given by 100 Newton. And mass per unit length is given by minus 2, so it will be 100 times 10 to the power of 2, so it will another 100, so the speed will be 100 meter per second. Okay, so the answer is 100 meter per second. Next question. An equivalent. Now from here on, we have already completed oscillations and wave chapters. Now we will move into the ray optics chapter. Ray optics is very, very important chapter. 4 questions approximately comes from this chapter. Okay, whereas from waves and oscillations, one question comes every year. But from ray optics chapter, 4 questions comes. So definitely all of your second few chapters are very important. This is one of the important chapters. That's why we are covering this in our KPL. Let's start with question number 16. An equiconvex lens made of glass of refractive index 3/2 has a focal length f in air. It's completely immersed in water and refractive index 4/3. The new focal length will be. So what is the refractive index of the glass? Refractive index of the glass is 3/2. The refractive index of the water is 4/3. Okay. So this is the information that is given to us. First we will apply the lens maker's formula. Equation or formula, whatever you are comfortable with. Okay, that is 1/f equals to n minus 1 1/r1 minus 1/r2. Now this part will be constant throughout our calculation. So from now on I will not show this part. This is constant and it will eventually cancel. Okay, we are mainly interested in this part. Okay, so first case, when it is kept in air, so directly the refractive index of glass is applied. So what is the value of 1/f? So 1/f, suppose this constant, I am saying this constant is equals to capital X. So I will write capital X. I will not ignore that. I cannot do that. So Ng is 3/2 minus 1 times capital X, or 3/2 minus 1 means half capital X, or f equals to 2 by x. So we have calculated the focal length. Next is when you immerse the lens into the water, the refractive index of the glass with respect to water is given by refractive index of glass divided by refractive index of water. Okay, so refractive index of glass is 3 by 2, refractive index of water is 4 by 3. So the relative refractive index is 9 by 8. This is called relative refractive index. You have learned this in your class 10th if you have studied light chapter, okay, and if you have ignored it, then you have to learn it right now. This is called relative refractive index, and relative refractive index is basically the ratio of the medium which we are considering divided by the surrounding medium or the environment, right? So this is how you can calculate. Now what is the focal length now? So focal length now, say f dash. F dash will be this NGW minus 1 times x. X is constant, 1 by r1 minus 1 by r2. Again, now what is 1 NGW? It is, we know that is 9 by 8 minus 1 times x. 9 by 8 minus 1 is 1 by 8. Okay, so this is the value. So this kind of equation shortcuts you have to memorize, you have to practice, so that you are whenever you see some kind of like this, so if the value is x plus 1 by x, okay, minus 1, the answer will always be 1 by x. Okay, you can try this and you can tell me if you find any difference. So 9 by 10 minus 10 by 9 minus 1 is 1 by 9. Okay, 11 by 10 minus 1 is 1 by 10. Okay, these are the things that you have to remember. So here 9 is 1 more than 8. So 9 by 8 minus 1 is 1 by 8. So now we can calculate f dash. F dash is basically 8 by x. Right? So x by 8 was there, but that was 1 by f. So f dash will be 8 by x. Now we are trying to find f dash by f. That is 8 by x divided by 2 divided by x, or 8 by 2 equals to 4, or f dash equals to 4f. Okay, so the correct answer is option C. Okay, clear? Question number 17. A mark is made on the bottom of a beaker and a liquid of refractive index 1.2 is poured to a height of 6 cm. When viewed vertically from the top, the mark seems to be raised by an amount in centimeter. So here we have a liquid, okay, and you have poured some water and you have made a mark here. Now when the refractive index of the liquid is 1.2, and when you view it from above after the liquid is dropped, you will not see at this depth, but you will see slightly raised. So how much amount it raised? So first we will find this distance. So this distance is v, okay, and this is the original distance. We always represent original distance by u and apparent distance by v, right? That is image distance, object distance. For a liquid, in this case it is given by, refractive index is given by u by v. This is a shortcut relation that you can remember, okay, or v equals to u by n. What is u? U is 6 cm original distance and refractive index is 1.2, so it will be 5 cm. Now don't mark 5 cm as your answer. This is not done. They have asked by how much the mark will raise. The mark will raise by, this is 5 cm, this much is 5, this much is 6. So how much it raised? Raised by 1 cm. 6 minus 5, that is, it raised by 1 cm. Be careful, okay, answering such questions. Next question, 18. A point source of light is kept below a surface of water. In water is equals to 4 by 3. The depth of √7 meter. The radius of the circular bright patch of the light noticed on the surface of the water is. Now this same question came 2024 PU2 final exam. Okay, PU2 final exam, same question came. The data was slightly different. Okay, here the data is given such that the calculations is slightly easier. In that case, you need to do slightly more calculations, but the concept is same. Okay, so if you think that this question is difficult for me, but this question is a PU level question. Marks wise different. Obviously in PU you have to answer more question. 100 marks is there. In KCET only 60 marks is there. So in PU2 the question was 5 mark question. In this case this is just a 1 mark question, but that 1 mark matters, right? So here is the water level. Okay, now when you put some the depth is √7. So light, suppose this is the light, we have kept the light here. The depth is √7. Now why do we see a circular patch of light when we put it under the water? You can try this in your home also, but you have to have a watertight light. Okay, if you have any light that works underwater, okay, does not damage it, you can try it using your high, or you can use a glass bottle. Okay, light up LED below the glass, and you can see that there will be only a circular patch on top of the glass, right? Now why there is a circular patch happens, that is the most important concept. So when the light travels, okay, at the critical angle theta c, okay, then the light, instead of going into the first medium, it comes between the two medium, and any more angles it will come back to, any more greater angle it will come back to the first medium, right? So in that case what happens is that light is traveling from denser medium to rarer medium, so any other light will bounce back into the first medium itself. So there will be no more light coming out other than this bright patch, this circular patch, right? So this is the patch of the radius. So this is how we will solve this question. So we will apply some geometry. What geometry will apply? We'll apply that this angle is theta c and this is the radius. This distance is the radius, right? Depth is given. We are trying to find this radius, and we also have to calculate the relationship between theta c and r. Refractive index is also given, 4/3. Right? Now we know that if the angle of critical angle is theta c, then 1/sin theta c is given by refractive index, that is 4/3, right? Or sin theta c is equal to 3/4. Okay, so if it was 3/5 it would have been easier for us, but it is given as 3/4. Now what we have to do, we have to calculate cos theta c, or rather we will directly solve tan theta c. What is tan theta c? Tan theta c is sin theta c divided by cos theta c. So sin theta c is, obviously we know that 3/4, and by cos theta c. Cos theta c is square root of 1 minus sin square theta c, that is 3/4 whole square. Okay, so you can simply cancel that, or do it like me. So 4 square, it will be 16 minus 9. Okay, or 3/4 divided by square root of 7 divided by 4, this 4 cancels, 3/7 is the answer. So 3/7 is the value of tan theta c. You can do it longer way, or you can simply, if you understand the concept of tan and cos, you can do it in your hands as well. Okay, you don't need to do this long mathematics. Okay, what is the method? Shortcut method is, first you write whatever sine means, perpendicular by hypotenuse, right? So perpendicular is 3, tan theta is perpendicular by base. Now what is base? Base is basically hypotenuse square minus perpendicular square. So this is the shortcut method, 3/7. You can apply this method as well, whatever method you are comfortable with. So basically what we are doing, we are saying that this is perpendicular and this is hypotenuse. Okay, so this is the shortcut method, but most people are not very comfortable with shortcut method, especially for trigonometry, and so I solved it in a longer way, and now I have done the shortcut way as well for the smarter students. Now let's find the value. So this is R, this is D, okay, and this angle is theta C. So you can say that tan theta C is equal to D by perpendicular by base, right? Perpendicular in this case is R and base is D, right? Perpendicular, this is the angle, so opposite angle is perpendicular and the adjacent angle is the base, right? So R by D, that is R we are trying to find, D is given root 7, and tan theta C we have already calculated, 3 by root 7 equals to R by root 7, or root 7 cancels, so R equals to 3 centimeters. Okay, so the answer will be not centimeter, it will be in meters. Everything is given in meters, so the answer will also be in meters. Okay, so this is the answer. Next question. A ray of light traveling in a transparent medium of refractive index n falls on a surface separating the medium from the air at an angle of incidence of 45 degrees. For which of the following value of n the ray can undergo total internal reflection? So they have said that the angle of incidence is 45 degrees, and they ask for which angle there is a possibility of total internal reflection. So we know that if the refractive index is given by n, then the relationship between critical angle and n is given by this. Okay, so you don't need to find sine inverse for each of them. That is the shortcut way. So sine theta C, if there was a total internal reflection, then this 45 degree angle, you can consider this angle as the critical angle. If any ray has to suffer total internal reflection at the angle of 45 degrees, then they definitely this should be the minimum value is critical angle. Okay, it should be slightly more than critical value, but you can consider this angle to be the critical angle. Now let's find the value of n. So sine 45, now we know that sine 45 is 1 by root 2. Okay, now it will go up, so n equals to root 2. Now what is the value of root 2? 1.414, right? So n value is 1.414. Now if the refractive index is more than this value, if the refractive index is more than this value, then there will be total internal reflection. This is the minimum value, right? So we consider this to be the critical angle. So this is the minimum condition for at least it will be grazing through the medium. Okay, anything slightly 0.1 degree more than 45 degree, there will be total internal reflection. So this is the minimum value for the refractive index. Now if anything greater than this, there will be total internal reflection. Now if in the given data only correct answer is 1.50. Don't get tempted and mark 1.4. Okay, so I got 1.414. So by rounding off, it seems like 1.4 is the correct answer. No, the logic here is it should be more than this value. Okay, so be careful and be vigilant when answering such tricky questions. Okay, this is a tricky question, even though the mathematics, the formulas are easy. Okay, but the trick is that the whatever value you are getting, that is the minimum value. Any value greater than that should be the answer. So 1.50 is the answer. Next question, question number 20. I think I answered this question multiple times. Let's answer this one more time. Ray of light passes through 4 transparent media with refractive index n1, n2, n3 and n4 as shown in the figure. The surfaces of the all media are parallel if the emergent ray DE is parallel to incident ray AB. Okay, so the incident ray AB and the emergent ray DE are parallel, then definitely this refractive index and this refractive index should be same. So in case of glass slab, if you remember, because the refractive index here is also air, here also air, okay, after refraction it becomes parallel, right? In between there's some refraction happens, so incident ray and emergent ray are parallel, so you can say definitely N1 should be equals to N4, so N1 is equals to N4. Okay, this is a simple answer. Next question. If a glass rod is put in a beaker containing a colorless liquid, the glass rod immediately seems to disappear. This is so because, so you have a glass rod in a liquid. Okay, so suppose this is a liquid, and if you add a glass rod, it disappears. How can the glass rod be disappear? Okay, so the glass rod can disappear. So if you see, can you see the glass rod? I have put it inside the liquid, right? But you cannot see the glass rod. Why? Because the refractive index of the medium of the liquid is equal to the refractive index of the glass, so that they merge with each other very quickly. So that's why they disappear. Okay, so the glass and the liquid have the same refractive index. Okay, the glass and the liquid have the same refractive index, not the color. Color does not matter. Okay, it does not matter about the density. Only thing that matters about optics is the refractive index, right? Next question. A diver on a diving board estimates that the depth of a water is swimming pool to be 18 meters. Percentage error in the estimation is, so refractive index of water is 4/3. Now this is the reverse question. We have solved one question where the initial depth was given and we are trying to find the final depth, right? Then we have found how much difference was there. Now here they have said that from the diving point, suppose here is the diver located. Okay, from here before diving he measures that the water is the depth of the water, apparent depth of the water is 18 meter. Okay, the apparent depth of the water is 18 meter. What is the actual depth? So actual depth, say actual depth of the water, say capital D. Okay, so this is basically our U, this is basically our V. Now we know that formula is N equals to U by V. So U we do not know, V is given as 18 meters, right, and N is given as 4/3. Okay, so we have to calculate the value of actual depth, capital D. Okay, U is given by capital D, so let me use the value capital D here. So capital D is basically 4/3 times 18, that is 6, that is 24. So 24 is the actual depth. Now they have not asked you about the actual depth, they have asked you the percentage error. So how to do the percentage error? So what is the difference in the measured depth versus the real depth? Okay, so measured depth or viewed depth by minus actual depth minus viewed depth, that is 24 was actual depth and he measured it to be 18 meter, so the difference is 6 meter. Okay, now what is the percentage error? Percentage error is the difference divided by the actual value times 100%. Okay, so it will be 4 will be 25, so the answer is 25%. So the diver before diving into the water, he actually measured the depth to be less than actual what depth is. Okay, so that gives him a 25% error chances. Okay, next question. Which mirror is to be used to obtain a parallel beam of light from a smaller lamp? So parallel beam of light from a smaller lamp, that means when you place a small lamp at the center of curvature of a concave lens, after reflection it becomes parallel, right? We know that when an object is kept at the focal length of a concave lens, they form an image at the infinity, so only a concave lens can be used. Okay, only a concave lens can be concave mirror can be used. Okay, if the same question was asked using a lens, okay, now tell me in the comment below what type of lens you will use to get a parallel beam of light. Okay, what type of lens you will use to get a parallel beam of light using a small lamp? Mention in the comment. I will reply. Question number 24, another easy question. Okay, this question may be very confusing, but it's actually a very easy question. The frequency of light ray is 6 times 10 to the power 14 Hz in air. Its frequency when it propagates in a medium of refractive index 1.5 it will be. The frequency of light is the fundamental property. It does not change on changing the medium. Only wavelength of light changes. Frequency does not change. So frequency will remain the same. So 6 times 10 to the power 14, it will remain 6 times 10 to the power 14. It will not change. Very careful. Okay, next question. A linear object of height 10 centimeter is kept in front of a concave mirror of radius of curvature 15 centimeter at a distance of 10 centimeter. The image formed is. So what are all the information? A lot of information is given. So one by one, height is 10 centimeter kept in front of a concave mirror of radius of curvature 15 centimeter at a distance 10 centimeter. Okay, radius of curvature is given, r is 15, okay, u is 10 without sign. The image formed. They have not asked you to do any calculations. They only asked you what will be the nature of the image. So we can ignore the height. We do not need the height right now. Okay, what we have to identify is where the object is located. Based on that, we can say what will be the nature of the image. So here we can see that the focal length is basically r by 2. So focal length is r by 2, that is 15 by 2, that is 7.5. So the focal length is 7.5 centimeter and the object is placed at a distance 10 centimeter. And the center of curvature is obviously at a distance 15 centimeter. So the object is placed between center of curvature and focal length, right? So if the object is placed between center of curvature and focal length, you will get a very magnified image, but that is beyond C. Okay, the magnified image will be beyond C, but real image. Okay, so real image means it is magnified and inverted. So magnified and inverted is the answer. Okay, next question. A beam of parallel light rays is incident on a solid transparent sphere of refractive index mu. If a point image is produced just at the back of the sphere, what is the refractive index of the sphere? So here we have a sphere. Parallel ray is falling on the object, and after refraction they are forming an image here. Okay, so this is the suppose the radius. Okay, then what is the total distance? Total distance is r plus r, that is 2r. Right, now we know that for a refraction through a spherical surface, the equation of is given by n by v minus 1 by u. Here it is air, obviously. Okay, so air equals to n minus 1 divided by r. Right, now let's find the values. N by v is here is v is 2r. So this is the entry point, this is the v, so v is 2r minus what is u? U is object is parallel rays are falling on the glass sphere, so the object is at infinity definitely, so it will be 1 by infinity equals to n minus 1 by r. Okay, so n by 2r equals to n minus 1 by r. R cancels, so n equals to 2n minus 2. Okay, so this is the whole value, right? We assume that other medium is air, right? So I think they have mentioned it somewhere here. Solid transparent medium, so refractive index mu, the point produces just a back. Okay, we are assuming that this is the air, that's why we have considered this to be 1, right? So now we have to find the value of n from this equation. So n minus 2n equals to minus 2, or minus n equals to minus 2, or n equals to 2. Okay, so 2 is the correct answer. Okay, you have to remember this equation. Okay, there is a general equation for refraction through a spherical surface. That is very important relation. You can remember that n1 n2 my n1 by v is equal to n2 minus by n1. Okay, that is the formula that you have to remember. Okay, now the image of an object in concave lens is formed at f2, where f is the focal length of the lens. Find the distance of the object from the lens. So the image formed in a concave lens. The concave lens focal length is plus f. Okay, focal length is plus. Okay, the image is formed at f by 2. So image is virtual. So we know that concave lens forms virtual images which is same side as that of the object. So v will be minus f by 2. We have to find what is u. Okay, so let's apply the formula. Lens equation, 1 by v minus 1 by u equals to 1 by f. Okay, so what is 1 by v? 1 by v is minus f by 2 minus 1 by u equals to 1 by f. Okay, or minus 2 by f minus 1 by u equals to 1 by f. We are trying to find 1 by u, so let us take this minus 1 by u to the other side and bring it in this side. Okay, so minus 2 by f minus 1 by f equals to 1 by u, or it will be minus 3 by f u. So u equals to minus f by 3. Okay, now unfortunately no option is given, so you can consider this to be a bonus question. This is a bonus question. Okay, next question. Blue color of sea water is due to image of the sky in the water, refraction of sunlight, interference of sunlight, reflection of the water on the surface, scattering of sunlight by the water molecules. So basically it is a blue color of sea water is the image of the sky in the water. Okay, the scattering happens in the atmosphere. Okay, and that's why the sky appears blue, and the same blue color is reflected by the water. So basically it's an image of the sky on the water. Okay, next question. The red color is used for danger signals because it causes fear, it undergoes least scattering, it undergoes maximum scattering. It is in accordance with the international convention because it scatters the less. That's why we can see the red color from very distance. Okay, and from the far, even if you may not be able to see the green color or blue color, but you can still be able to see the red color because it does not scatter. So it can warn you from the distance that there is a danger ahead. So that's why red color is used. A ray of light suffers a minimum deviation when the incident on a equilateral triangle or equilateral prism of refractive index √2. The angle of incidence is. Now what is the relationship between different angles in case of minimum deviation? So we know that the refractive index is given by sine A plus angle of incidence divided by 2 divided by sine A by 2. This is the formula we know. Now for an equilateral prism, all the sides are same, so the angle is 60 degrees, right? So all the angles are 60 degrees. So A is basically 60 degrees. So we can put that value here, and n is given here, refractive index is √2. Okay, so √2 equals to sine. Right now I am not putting the value in the first part, but in the below only A is there, so I will put it. A by 2 is obviously 30 degrees. right? So sine a plus I by 2 equals to root 2 sine 30 degrees. What is the value of sine 30 degree? Sine 30 degree is half. Sine 30 degree is half. So it will cancel, you will get root 2. So it will be equals to 1 by root 2. Now what is 1 by root 2? So sine theta equals to 1 by root 2. How to solve for theta? Sine theta equals to sine by root 2 means this is nothing but sine 45 degrees. Right, we already know that 1 by root 2 is sine 45 degrees. So sine theta equals to sine 45 degrees. So definitely theta equals to 45 degrees. Okay, so A plus I equals to 90 degrees. Okay, now 60 plus I equals to 90 degrees, or I equals to 90 degrees minus 60 degrees, that is equals to 30 degrees. So this is the answer. Okay, so we have completed all the solutions of this KPL 14. I hope you enjoyed this session. I will be back with the new KPL every week. So if you have not joined our WhatsApp channel, don't forget to join our WhatsApp channel. The link is given in the description. And if you have liked this video, don't forget to like, share and subscribe to our channel. Thank you.